practice paramida has returned, but its streak is glowing brighter, pulsing with strange energy after its trip behind the sun.
It began with a flash no one expected. A burst of green light tore across the edge of the sun, so bright that even NASA's telescopes went blind for a few seconds. Then, silence. For weeks, the skies offered nothing but static, as if the universe itself had taken a breath. When the systems finally came back online, something had changed. The interstellar traveler known as 3I/Atlas had returned from behind the sun, and it was glowing 10 times brighter than before. Its surface shimmered like metal, and its pulse of light followed a rhythm too precise to be random. Scientists called it a comet, but nothing about it behaved like one. Across observatories in Europe, the United States, and Japan, astronomers stared at the same impossible sight of a visitor from another star, now alive with strange energy. No one could explain what had happened during its disappearance, but one question echoed through every lab and control room on Earth. What exactly woke 3I/Atlas while no one was watching? Long before it returned, 3I/Atlas was already a mystery. Astronomers first detected it cutting through the solar system at an angle that no natural object should follow. Its orbit did not match the pull of any planet, and its speed was far beyond what gravity alone could explain. It wasn't just passing by, it was slicing through space as if guided by something unseen. For comparison, the famous Oumuamua and Borisov were also interstellar visitors, but both behaved as expected. They slowed slightly after their closest approach to the sun and drifted away quietly into the dark. 3I/Atlas did the opposite. Its velocity increased the deeper it went, as if something inside it was driving the motion. NASA's Jet Propulsion Laboratory and the European Space Agency began tracking it using multiple observatories, from Hawaii's Mauna Kea to Chile's Atacama Desert. Every dataset showed the same impossible pattern. 3I/Atlas came from far beyond the Kuiper Belt, a region filled with frozen relics, yet its materials were warmer, metallic, and active. When it disappeared behind the sun, experts expected to lose sight of it forever. But after 6 weeks, it came back glowing brighter than any known comet, forcing scientists to question everything they understood about interstellar travel. If it wasn't just rock and ice, what exactly traveled across the stars to reach us? And more importantly, what could have changed it while it was hidden behind the sun? For weeks, the sky had been silent. Telescopes around the world searched for a trace of 3I/Atlas, but it had vanished behind the sun's blinding light. Then, on a quiet morning at the Mauna Kea Observatory in Hawaii, a signal appeared. A thin green spark cut across the blackness of space. Within minutes, sensors confirmed what no one expected. The interstellar traveler was back, and it was brighter than ever before. At first, astronomers thought it was a glitch, maybe a reflection or a solar flare bouncing off the sensors. But when more observatories across Chile, Spain, and Japan picked up the same pattern, the truth became impossible to ignore. 3I/Atlas was glowing with a strength that defied physics. Its brightness had increased by more than tenfold in less than a day. The energy output was too high for ice or dust to explain, and the glow was strangely rhythmic, pulsing, almost breathing, as if the object had a heartbeat. The colors were equally strange. Ordinary comets glow white or blue, reflecting sunlight off their icy surfaces. But 3I/Atlas radiated an emerald hue with flashes of gold and silver. Spectral scans revealed spikes in ultraviolet and X-ray frequencies, something no natural comet had ever produced. It was releasing powerful bursts of radiation without showing signs of melting or losing mass. It looked less like a comet and more like a machine awakening after a long sleep. NASA and ESA immediately began cross-checking data. They compared the current readings with its first appearance months earlier. The difference was staggering. The intensity of the light wasn't random. It followed a fixed rhythm of 8.4 seconds between each pulse. That consistency suggested a pattern, a deliberate signal rather than a natural reaction. Some scientists dismissed it as coincidence, the product of rotating debris. Others quietly admitted they had never seen anything so perfectly timed. What made the mystery deeper was how 3I/Atlas handled sunlight. Normal comets break apart as they near the sun, losing ice and gas in dramatic tails. But this object seemed to do the opposite. The closer it came, the stronger and more stable it became. Its surface temperature rose, yet it didn't fragment. Instruments from NASA's Solar Dynamics Observatory recorded a layer of vaporized metal forming around it, almost like armor. That protective layer somehow reflected radiation while amplifying its internal glow. Then came the flares. For several hours, 3I/Atlas released bursts of ultraviolet energy, lighting up NASA's sensors and triggering alerts across monitoring stations worldwide. The spikes matched neither cosmic rays nor known solar events. Every time the sun flared, 3I/Atlas responded a few seconds later as though reacting to the star's pulse. Some described it as synchronization. Others used a different word: communication. By the third day, scientists began to argue about what they were seeing. One group claimed the light came from chemical reactions deep within, possibly involving exotic carbon compounds or metallic hydrogen. Another group proposed that it was absorbing solar energy and converting it into light through unknown means. But one unsettling possibility kept surfacing in private discussions. The pulses were too regular, too intentional. What if the light wasn't a reaction at all? By the time the week ended, data from NASA, ESA, and Japan's JAXA confirmed the same rhythm across all instruments. The object was not only alive with energy, it was consistent, measured, and precise. Something inside it seemed to control the output, adjusting slightly depending on its distance from the sun. The world had seen comets burn, fade, and vanish. But this one brightened like a signal reaching across the void. It wasn't dying, it was responding, and the real question was, to what? When 3I/Atlas began to brighten, scientists believed they were simply watching another frozen traveler reacting to sunlight. But the deeper it moved toward the sun, the more it defied every prediction. Instead of breaking apart like ice, it seemed to thrive in the heat, almost feeding on it. What started as a faint green glow had transformed into a roaring pulse of ultraviolet energy. NASA's Solar Dynamics Observatory first captured the strange readings. The radiation spikes didn't match any solar flares, yet they followed the sun's cycle closely. Every time the sun released a burst of plasma, 3I/Atlas responded seconds later with its own flash. The timing was too precise to dismiss. It was as if the object was reacting to the star, not being destroyed by it. Some described it as a mirror reaction. Others whispered it looked like a two-way exchange of energy. European researchers tried to simulate the behavior in controlled experiments. They exposed metallic and carbon-based materials to extreme solar heat, attempting to reproduce the pattern. None of them emitted the same type of light. The wavelengths from 3I/Atlas included bands that didn't exist in any known element found in the solar system. It was as if it contained materials older than the sun itself, or forged in a completely different kind of star. Theorists began calling it the Sun's Experiment, an interaction between our star and a foreign object that challenged the limits of astrophysics. Some speculated that the heat triggered a dormant process inside the comet's core, awakening ancient compounds buried since it left its home system. Others thought it was the opposite. The object was deliberately using the sun's radiation to refuel, converting light into motion through an unknown mechanism. By midweek, Japan's Hinode telescope detected an even stranger phenomenon. A halo of ionized gas had formed around the object, spinning in perfect symmetry like a containment field. The gas rotated at different speeds, creating magnetic waves that amplified the ultraviolet output instead of weakening it. This behavior suggested that 3I/Atlas was somehow controlling its own environment, stabilizing itself against the sun's pressure. The data stunned researchers. The object's thermal readings remained constant, showing no signs of melting even as it passed through temperatures high enough to vaporize steel. If it had a solid core, that core was unlike any known rock or metal. Its resistance to heat seemed intentional, like a shield built to withstand the furnace of a star. Meanwhile, a team at ESA noticed another clue. During one of the energy spikes, the object briefly emitted light in a fixed rhythm: 3 short flashes, a pause, and 1 long beam. The same pattern appeared 3 times over the course of an hour. When scientists converted the light sequence into binary code, it formed repeating pairs of 1s and 0s. Statistically, that repetition could not be random. The discovery sent a quiet shock through the community. No one publicly claimed it was a message, but behind closed doors, agencies began encrypting data transmissions and limiting public updates. For the first time, the 3I/Atlas project became classified. To the public, the explanation was simple: solar interference. But to those who had seen the raw data, the pattern told a different story. Something inside that glowing traveler was responding to the sun like a partner in a silent experiment, exchanging energy, data, or perhaps something far more advanced. The question was no longer whether 3I/Atlas survived the sun's heat. The question now was, what had it learned from it and what would it do next? When scientists finally analyzed the light from 3I/Atlas, what they found was unlike anything they had ever recorded. The first spectral scans showed strange peaks that didn't match any known element. It was neither ice, rock, nor metal in the usual sense. The signature was alien. Comets normally contain water, carbon dioxide, and traces of silicon. They are frozen leftovers from the birth of solar systems, simple in composition. But 3I/Atlas carried a chemical fingerprint that broke every rule. Its spectrum contained high levels of nickel, but almost no iron. In nature, these two metals are always found together because they form in the same stellar process. Having one without the other made no sense. It was as if the object had been manufactured instead of born. NASA's Goddard Space Flight Center confirmed the anomaly with its ultraviolet spectrometer. The ratios between carbon and oxygen didn't match any celestial body ever observed. Some readings even suggested the presence of compounds similar to nickel tetracarbonyl, a toxic substance used in industrial refining on Earth. That discovery alone sparked one of the most heated debates in modern astronomy. Could an object traveling from another star carry something that looked like a product of engineering? The question divided the scientific community. Some argued it was coincidence, a natural mix created under extreme cosmic pressure. Others quietly admitted that the pattern looked engineered. A research team from the European Southern Observatory noticed that the light frequencies weren't random. They repeated at measured intervals, hinting that each wavelength carried information. When the data was converted into visual form, it created geometric patterns, perfect hexagons and triangles glowing within the green light. This discovery led to a new hypothesis. What if the glow wasn't a byproduct of chemistry, but a language of light? In deep space, radiation can't carry sound, but it can transmit structure. Some scientists began to suspect that 3I/Atlas was broadcasting encoded signals through its chemical emissions. Each pulse, each color shift, could represent a data stream meant to be detected, not just seen. To test this, observatories compared data from different countries. Japan's Subaru telescope and Chile's VLT recorded the same patterns at the same time, despite being half a world apart. The consistency ruled out local interference. Whatever 3I/Atlas was doing, it was deliberate. The emission stayed stable for days, repeating its pattern with mathematical precision. The more they studied it, the stranger it became. Within the ultraviolet range, scientists detected micropulses shorter than 1/10 of a second. When plotted on a time graph, these flashes formed mirrored sequences, symmetrical and organized. No natural process known to science produces light behavior that is clean. To many, it began to look less like a comet and more like a transmitter. And yet, the object remained silent in every other frequency. No radio signals, no microwaves, no gravitational anomalies. It was as if it wanted to be seen but not heard. The message, if it was one, was entirely visual, a pattern written in light for anyone who could decode it. By the end of the month, NASA's public reports stopped mentioning the chemical data altogether. Private documents leaked later suggested that several agencies were working to translate the sequences, treating them as potential communication rather than noise. If 3I/Atlas truly carried the chemistry of another civilization, it would change everything humanity knew about life and intelligence in the universe. The question was no longer how it glowed, but why it glowed and who wanted us to see it. By the time the world realized what 3I/Atlas was doing, it was already too late to look away. Every major observatory from NASA's Deep Space Network to the European Southern Observatory was locked on the object, yet something strange began to happen. The more they focused on it, the more it seemed to respond. At first, the changes were subtle. Every time a telescope adjusted its sensors, 3I/Atlas emitted a faint increase in brightness, as if acknowledging the observation. When instruments zoomed in for higher resolution, the glow dimmed slightly, like it was reacting to being studied. Scientists called it coincidence, but the pattern kept repeating across multiple countries, in different time zones, under separate control systems. In Japan, the Subaru telescope recorded a series of light pulses that appeared moments after a data transmission was sent to NASA. The timing matched to the second. In Chile, researchers at the ALMA array noticed the same phenomenon when they sent calibration signals toward its trajectory. The object responded with a mirrored pulse of light, precise, deliberate, and silent. It was not possible for a natural comet to react in real time across hundreds of thousands of miles. The global scientific community entered what journalists later called the quiet panic. Behind closed doors, data centers started isolating servers, preventing leaks to the public. What they didn't want to admit was terrifying. 3I/Atlas was acting like it knew it was being watched. Satellite telemetry began to reveal another layer of mystery. Each time a new observatory locked onto the object, the data stream from other facilities showed a fractional change in its rotational axis. It was as if the object adjusted its position to keep one side facing Earth, similar to how the Moon always shows the same face. This motion was too controlled to be coincidence. Even the Mars Reconnaissance Orbiter detected something unusual. During its routine scan, a faint burst of green light appeared near the object's path, exactly when Earth-based telescopes were observing it. That meant the phenomenon wasn't local. Whatever 3I/Atlas was doing, it was visible across planets. Engineers noticed that the light pulses weren't just visual. They carried electromagnetic noise that formed harmonic waves when analyzed through audio converters. When converted into sound, the signal resembled a slow rhythm, steady, low, almost musical. Some described it as a heartbeat. Meanwhile, smaller observatories and even amateur astronomers began reporting unexplained interferences. Cameras glitched, and tracking software froze when pointed at the object. The interference wasn't damaging, but it behaved like a feedback loop, bouncing energy back to the source. Some wondered if it was defensive, as though 3i/Atlas was protecting its signal from being decoded. At the European Space Operations Center, analysts discovered one last detail that unsettled everyone. The timing of the light pulses matched the schedule of Earth's radio transmissions sent toward it. The object wasn't just reflecting light, it was mirroring human contact attempts, but with a delay of exactly 9 seconds. That delay could only exist if it was processing and then returning the signal. To some, that was proof of intelligence. To others, it was the most advanced coincidence in history. Either way, the message was clear. The moment humanity looked up, something out there looked back. The world had turned its telescopes toward the sky to study an object, but now that object was studying us. And if it was capable of reacting to our gaze, what else might it be capable of doing next? As the glow of 3i/Atlas began to fade, the world expected an ending. Telescopes prepared to record its final moments, but what they captured was something no one had seen before. The object did not vanish into darkness or break apart into dust. It slowed, then stopped suspended between Earth and the Sun, as if time itself had paused around it. NASA's tracking systems showed a deliberate deceleration, far too precise to be accidental. The change in speed was minute, yet the force behind it was extraordinary. To scientists, it looked like controlled braking, not the drifting motion of a dying rock. Even more unnerving was its stability. Despite gravitational pull and solar radiation, 3i/Atlas held its position perfectly, like a spacecraft maintaining orbit. Spectral data revealed its brightness fading in layers, each pulse weakening by the same percentage every 12 minutes. It wasn't a chaotic collapse, but a calculated sequence, as if systems were shutting down one after another. Engineers at the Jet Propulsion Laboratory described it as a mechanical pattern, not a natural one. Something inside seemed to be powering off step by step, almost like a countdown. Then came the silence, but not complete silence. At that very moment, radio observatories across the world detected faint rhythmic echoes. The frequencies came from the same region of the sky where 3i/Atlas had paused. In Chile, the ALMA array recorded a wave that lasted 9 minutes and 30 seconds before vanishing. The signal repeated exactly 3 times, each identical in length and tone. When amplified, it produced a deep, steady rhythm that sounded eerily like a heartbeat. For a few days, scientists dismissed it as interference from solar activity, but the same pattern appeared again in Japan, Italy, and California, each time with identical spacing and frequency. That global consistency shattered any natural explanation. It wasn't random noise. Something was transmitted intentionally. Teams at NASA, ESA, and JAXA began decoding the echoes. The pattern contained harmonic intervals and mathematical divisions similar to musical chords. When the data was converted to sound, the signal became a slow, haunting melody that rose and fell every 93 seconds. It wasn't language, but it carried structure, rhythm, and emotion. Then, an analyst at ESA made a discovery. Within the echo's amplitude, the waves formed groups of 3, repeating the same digital ratio, 3-1-0. When mapped against the object's original trajectory, those numbers aligned perfectly with its first recorded coordinates entering the solar system. To many, this was a coincidence. To others, it was proof of deliberate design, a calling card left behind. Meanwhile, NASA's public updates grew shorter. Officials claimed the object had fallen below visible brightness, but leaked reports revealed the light had not vanished instantly. It faded gradually, pulsing slower each time until finally there was nothing left. The rhythm of the light mirrored the rhythm of the radio echo. Both stopped at the same moment. To astronomers, that synchronization was chilling. For months they had watched 3i/Atlas behave as if it were alive, brightening, reacting, even communicating. Now it had fallen silent, but the silence felt heavier than noise. One researcher described it as a conversation that ended mid-sentence. Even after it disappeared, radio telescopes continued to hear faint interference along the same trajectory. The signal came and went irregularly, sometimes weak, sometimes strong, as if a fading memory was still trying to reach out. NASA labeled it solar reflection, but independent scientists suspected otherwise. They believed 3i/Atlas was still there, hidden in plain sight, waiting. The mystery left a mark that science could not erase. If it truly was just a comet, why did it slow down, send a patterned signal, and then fall quiet as if completing a mission? Perhaps 3i/Atlas wasn't dying. Perhaps it was resting. And if that silence was not the end but a pause, then who or what was it waiting for? 3i/Atlas entered our skies as a mystery and left as a warning. It challenged everything we thought we knew about comets, about motion, and even about the silence of space itself. For months, scientists watched it glow, react, and communicate in ways no natural object ever had. And then, when it faded, it left behind a silence that felt almost alive. Some say it was just a piece of interstellar ice wandering without purpose. Others believe it was something far greater, a machine, a messenger, or even a seed from a civilization older than our own. Whatever the truth is, it forced humanity to confront one terrifying question. What if we are not just observers of the universe, but participants in a conversation that has only just begun? Because if 3i/Atlas can watch us once, what will happen when it decides to speak again?